Critical minerals are becoming the new base layer of the global economy. Not because the world runs out tomorrow, but because demand is rising across multiple systems at once, and the map of supply is concentrated. Batteries need minerals. Power grids need minerals. Data centers and electrification need minerals. Defense systems need minerals. And when the same inputs feed multiple industries, those inputs become leverage. That's why the next decade will be shaped not just by technology but by minerals. And the most important part isn't only mining. It's the minerals map. Who controls extraction, who controls processing, and who controls the choke points in between. Let's start with the simplest idea. In the modern economy, production depends on inputs. If you control the inputs, you influence the pace of building. And right now, the build cycle is expanding. EVs and battery storage are scaling. Grids are being upgraded. AI infrastructure is expanding. And industrial policy is pushing domestic manufacturing. All of that increases mineral demand. This is why minerals are not just commodities anymore. They behave more like strategic infrastructure. Now, the minerals map has 3 layers. Layer 1, extraction. This is mining, where raw materials come out of the ground. Layer 2, processing and refining. This is where raw material becomes usable industrial input. Layer 3, manufacturing integration. This is where minerals become batteries, motors, cables, chips, and defense components. Most people focus on Layer 1, but the real leverage often sits in Layer 2. Because even if you mine the material, you still need it processed at scale, consistently, and affordably. That processing capacity is concentrated. And concentration creates leverage. Now let's talk about the minerals that matter most. Copper is the metal of electrification. If you want a stronger grid, you need copper. If you want EVs, you need copper. If you want renewable build-out and transmission, you need copper. If you want data centers, you need copper. Copper demand is structural because it's tied to electricity moving through the economy. So when you see the power era, you should also see copper. Lithium is the battery headline mineral. Storage demand is growing. Not only EVs, but grid storage. Even as battery chemistries evolve, lithium remains central for many pathways. Nickel often matters for energy density in certain batteries. Not every chemistry depends on it equally, but when demand spikes in nickel-heavy chemistries, it becomes a pressure point. Rare earths are less about volume and more about strategic functionality. Permanent magnets matter for EV motors, wind turbines, and specialized systems. And the key is not only mining, it's separation and processing. Now here's the minerals map reality. The world can have enough minerals in the ground and still face constraints. Because mining can take years, permits take years, financing and construction take years, and processing ecosystems take even longer. So the constraint isn't only resource availability, it's timeline and capacity. That's why mineral cycles tend to create spikes and shortages during build booms. Now, who wins in the minerals decade? It's not always the country with the most minerals underground. It's the country that can do 3 things. Produce reliably, process at scale, integrate into manufacturing supply chains. Reliability matters because companies can't build trillion-dollar supply chains on uncertain input access. Scale matters because demand is rising across multiple sectors at once. Integration matters because processed material needs to flow into actual factories and products. This is why the minerals map is also an industrial policy story. Countries are trying to build domestic processing and refining, not because it's easy, because it reduces dependence. If processing is concentrated in one region, that region gains leverage. Export controls, quotas, or policy shifts can ripple globally. So many countries are trying to de-risk by diversifying processing. That takes time. And during that time, the leverage remains. Now, what does this mean for the economy? It means the speed of electrification and infrastructure build-out can be constrained by inputs. If copper is tight, grid upgrades slow. If processing capacity is constrained, battery scale slows. If rare earth processing is constrained, magnet supply tightens. And when inputs tighten, prices rise. Those price moves can feed into inflation in certain industrial categories. This doesn't mean inflation everywhere. It means inflation pressure in strategic build sectors. So mineral constraints become a cost layer under the next decade's capex cycle. Now here's the part people underestimate. Minerals are not only an energy transition story, they're a security story. Defense systems rely on specialized components and materials. Strategic stockpiles become more important. Supply chain independence becomes more important. So minerals sit inside geopolitics now. That means volatility, policy risk, and competition for long-term contracts. So what should you watch as the minerals map shifts? Watch 5 signals. 1. Processing buildout. New refineries, separation facilities, chemical plants, and midstream capacity. That's where dependence gets reduced. 2. Long-term supply deals. Automakers, battery firms, and governments locking in supply. That signals scarcity anxiety. 3. Export restrictions and policy moves. When a country restricts exports of a key input, it's leverage. 4. Permitting and project delays. Delays shrink future supply and raise probability of tight markets later. 5. Substitution trends. Chemistry shifts can change which minerals matter most, but substitution takes time and scale. Here's the takeaway. The minerals map decides the next decade because it decides what can be built and how fast. Technology matters. But technology still runs through physical inputs. And when inputs are concentrated, they become strategic. So the next decade's winners won't only be those who invent. They'll be those who secure reliable mineral supply chains, extraction, processing, and integration. Because in a world rebuilding grids, scaling AI infrastructure, and electrifying industry, minerals aren't optional. They're the foundation.